Hello to everyone. Myself, I am Syam Reddy,
Yeah,
lecturer in mathematics, PR Government Degree College Autonomous, Kakinada. On the behalf of Commissionerate of College Education AP, I am welcoming you e-learning management system. E-learning on the topic parallelogram law. This topic belongs to second year BA or BSc mathematics subject in fourth semester. In fourth semester, the paper is titled as linear algebra. In linear algebra, before going to learn about the topic parallelogram, first we will discuss the learning outcomes of the parallelogram law. So after studying this inner part space, a student will be able to recognize the following properties of a parallelogram. First one, describe the relationship between opposite sides in a parallelogram. That is, opposite sides are parallel and opposite sides are equal in length. Next, second one, describe the relationship between opposite angles in a parallelogram. That is, opposite sides are equal in measure. Next one, describe the relationship between consecutive angles in a parallelogram. That is, the sum of two adjacent angles is 180 degrees. Next one, describe the relationship between the two diagonals in a parallelogram. That is, the diagonals bisect each other. So, first we can discuss parallelogram law in geometry. So, in mathematics, the simplest form of the parallelogram law, also called the parallelogram identity, belongs to elementary geometry. It states that the sum of the squares of the lengths of the four sides of a parallelogram equals the sum of the squares of the lengths of the two diagonals. Here AB, BC, CD and AD are four sides and AC and BD are diagonals. So we use this notation for the sides AB, BC, CD and DA. So in Euclidean geometry, a parallelogram necessarily has opposite sides equal. That is, AB is equal to CD and BC is equal to DA. So the law can be stated as 2AB square plus 2BC square is equal to AC square plus BD square. So if the parallelogram is a rectangle, the two diagonals of equal length. That is, AC is one diagonal and BD is the other diagonal. So in rectangle, AC is equal to BD. So 2AB square plus 2BC square is equal to AC square plus BD is nothing but AC. So AC square plus AC square is equal to 2AC square. So 2AB square plus 2BC square is equal to 2AC square and the statement reduced to the Pythagorean theorem. So parallelogram in geometry, let AD is equal to BC is equal to X. So AD is equal to BC is equal to X and AB is equal to DC is equal to Y and angle BAD is equal to alpha. So using the law of cosine in triangle BAD, x square plus y square minus 2xy cos alpha is equal to BD square. Again, we know in a parallelogram, the adjacent angles are supplementary. That is, angle BAD is equal to alpha, then angle ADC is equal to 180 minus alpha. So angle ADC is equal to 180 minus alpha. Now again the using the law of cosine in triangle ADC, that is x square plus y square minus 2xy into cos of 180 minus alpha is equal to AC square. But in trigonometry, cos of 180 minus alpha is in second quadrant. Second quadrant is in second quadrant cos theta is negative and 180 minus alpha is equal to cos alpha. So in second quadrant, cos of 180 minus alpha is equal to minus cos alpha. So equation 2 becomes x square plus y square minus of minus plus 2xy cos alpha is equal to AC square. Now, the sum of the squares of the diagonals BD square plus AC square are represented as BD square plus AC square is equal to BD square nothing but x square plus y square minus 2xy cos alpha, and AC square nothing but x square plus y square plus 2xy cos alpha. So x square plus x square is equal to 2x square, y square plus y square is equal to 2y square, minus 2xy cos alpha plus 2xy cos alpha is cancellation. So BD square plus AC square is equal to 2x square plus 2y square. That is BD square plus AC square is equal to 2 into x represented as AB, y represented as BC. So BD square plus AC square is equal to 2 into AB square plus 2 into BC square, which is nothing but a parallelogram law. So in parallelogram identity in inner product spaces, that is, if V is an inner product space and alpha comma beta belongs to V, then the sum of the squares of the norms of the vectors alpha plus beta and alpha minus beta equals twice the sum of the squares of the norms of the vectors alpha and beta. That is norm alpha plus beta whole square plus norm alpha minus beta whole square is equal to 2 into norm alpha whole square plus norm beta whole square. That is sum of the norms of the vectors alpha plus beta, that is norm alpha plus beta whole square. Next, alpha minus beta is alpha minus beta, norm alpha minus beta whole square is equal to twice the sum of the squares of the norms of the vectors alpha and beta. That is 2 into norm alpha whole square plus norm beta whole square. Now, let me given data V is an inner product space and alpha comma beta belongs to V. Then norm alpha plus beta whole square plus norm alpha minus beta whole square is equal to 2 into norm alpha whole square plus norm beta whole square. Now we can prove. Now norm alpha plus beta whole square is equal to inner product of alpha plus beta alpha plus beta. So inner product alpha alpha plus inner product alpha beta plus inner product beta alpha plus inner product beta beta. So inner product alpha alpha is nothing but norm alpha whole square plus inner product beta beta is equal to norm beta whole square plus inner product alpha beta plus inner product beta alpha. That is norm alpha plus beta whole square is equal to norm alpha whole square plus norm beta whole square plus inner product of alpha comma beta plus inner product of beta comma alpha. Again, inner product of alpha minus beta whole square, norm alpha minus beta whole square is equal to inner product of alpha minus beta comma alpha minus beta. That is equal to inner product of alpha comma alpha plus inner product of alpha comma minus beta plus inner product of minus beta comma alpha plus inner product of minus beta comma minus beta. That is equal to inner product of alpha alpha is equal to norm alpha whole square plus inner product of inner product of minus beta comma minus beta is equal to norm beta whole square plus inner product of alpha comma minus beta is equal to minus of inner product alpha beta plus inner product of inner product of minus beta comma alpha is equal to minus of inner product beta alpha. So now inner product of adding the above two equations, norm alpha plus beta whole square plus norm alpha minus beta whole square is equal to norm alpha whole square plus norm alpha whole square is equal to 2 into norm alpha whole square, norm beta whole square plus norm beta whole square is equal to 2 into norm beta whole square. So both norm alpha plus beta whole square plus norm alpha minus beta whole square is equal to 2 into norm alpha whole square plus norm beta whole square. This is nothing but parallelogram law in inner product space. So geometrical interpretation of a parallelogram law. Let alpha comma beta be two vectors in the inner product space R³ with standard inner product. In three-dimensional space R³, we can take alpha is equal to AB bar, comma beta is equal to BC bar. So norm alpha is equal to AB, norm beta is equal to BC where A comma B comma C comma D are points. Then the vectors alpha plus beta, alpha minus beta represent the diagonals of AC bar comma DB bar of the parallelogram ABCD. So norm alpha plus beta is equal to AC. Norm of alpha plus beta is equal to AC. And norm alpha minus beta is equal to DB. From the parallelogram law theorem, norm alpha plus beta whole square plus norm alpha minus beta whole square is equal to 2 into norm alpha whole square plus norm beta whole square. That implies norm alpha plus beta nothing but AC. So norm alpha plus beta whole square is equal to AC square. Plus norm alpha minus beta nothing but dB. So norm alpha minus beta whole square is equal to dB square is equal to 2 into norm alpha nothing but AB. So norm alpha whole square is equal to AB square plus norm beta nothing but BC. So norm beta whole square is equal to BC square. That is AC square plus DB square is equal to 2 into AB square plus BC square. That is equal to 2AB square plus 2BC square. AB square is equal to 2AB square is equal to AB square plus BC square. And 2BC square is equal to CD square plus DA square. So AC square plus DB square is equal to AB square plus BC square plus CD square plus DA square. That is AC square plus DB square is equal to AB square plus BC square plus CD square plus DA square. That is the sum of the squares on the diagonals of a parallelogram is equal to the sum of the squares of the four sides. That is the sum of the squares on the diagonals of a parallelogram. AC is one diagonal and DB is the other diagonal is equal to the sum of the squares on the four sides. AB is one side, BC is another side, CD is another side and DA is another side. So the sum of the squares on the diagonals of a parallelogram is equal to the sum of the squares of the on the four sides. This is the geometrical interpretation of a parallelogram. So thank you one and all for watching this video.